Let's start here. Number one, we're going to reduce this rational expression, and we do that by factoring and canceling everything that's common. So let's factor this. So we're going to get, let's write our two parentheses, and I'm anticipating we can do this. How about x and x? And now for 48, let's check this. For 48, what do we want to do here? We could do 48 and 1. That's not going to get us that 14 when we add or subtract. I'm going to cut in half and double. I'll get 24 and 2. Cut in half and double again. How about 12 and 4? Cut in half and double again. We'll get 6 and 8. And now I think we've got it. The 6 and 8, when we add them together, we can get that 14. So let's use the 6 and the 8. So we'll get a 6 and an 8. And because the 48 is positive, these two numbers, the 6 and the 8, have the same sign, which is going to be that minus sign right there. I'm going to put a x minus 6, x minus 8. Now let's get this denominator. So this is going to be parentheses. How about x and x? And now we're looking for 24. So 24, I can see that one. That's going to be a 6 and a 4 because I can get a 2 out of that. And part of the hint is I've got a 6 up here. All right, so let's try this. Let's go with a 6 and a 4. And the 24 is negative. So these two numbers will have opposite signs. And I'm going to put that middle negative sign with the bigger of these two products. That inner product is 6x. This outer product is only 4x. This one's bigger. So I want to put the negative sign here. And I know it's kind of a hint it's going to match that one. So minus, plus, and now I can see that this x minus 6 here is going to divide out or cancel with that x minus 6. And we're going to be left with this. X minus 8 over x plus 4. And I'm going to go a step further. I'm going to say this is going to be true as long as x is not equal to, all right, just run it right back here. Look at that denominator right before. What can x not be? What's going to give us 0 here? Well, if x is 6, I'll get 0, and if x is negative 4, I'll get 0. So we're going to say x is not equal to 6 and negative 4. So we're going to try to reduce number 2 here. And let's see, we're going to factor, we know that. So let's write our parentheses, anticipating we can do this. Now I'm going to factor the denominator first because that's a difference of 2 squares. That's an easy one to get. This is going to be conjugate. So we're going to get 3x and 3x. I'll get a 2 and a 2. 1 will be plus, 1 will be minus. And now to get the numerator, we've got a 9 here. So the 9, we could use 9 and 1, 3 and 3. But look at the denominator. We got 3's here. I think we should go with the 3 and the 3. Give us a chance for something to cancel. So how about 3x and 3x? And then we need the 10. So the 10, now I could use a 10 and a 1 or a 5 and the 2. But because I got 2's down here, I think I'm going to go with a 2. So let's go with a 5 and the 2. Now, the 10's positive. So these two numbers have the same sign, that middle plus sign. So they're both going to be plus. And now I can see what happens here is that this 3x plus 3 will cancel with that one. And that will leave us here with 3x plus 5 over 3x minus 2. And this is going to work as long as x is not equal to, all right, take it back one step here. What's going to give us 0 in the denominator? Negative 2 over 3. So I'll get negative 2 over 3. And from this one, positive 2 over 3. There we go. Now here in number 3, what we're looking for are the values of x that make this expression undefined. Well, this expression is going to be undefined if the denominator is 0. So really all we need to do is see what's going to give us 0 down here. So what I'm going to do is I don't need to worry about the top. Tops can be zeros, but bottoms cannot. So I'm going to factor this one right here. So I'm going to rewrite this like this. I'm just going to factor the denominator. And, well, let's see. You know what? First of all, seems to me we can, when I look at it more carefully, I see I've got an x in each term. So I'm going to factor that x out. So this will give us an x, and then what? 4x squared plus 27x minus 7. Let's take this down. This will give us x. Here's our two parentheses. And let's see, we could try 4x and an x, or 2x and 2x. I tried this, so I'm going to go with 4x and x minus 1 and plus 7. Okay, it took me, I had to use, first of all, I tried 2 and 2. That didn't work. So this is what I'm getting for the factored form. So what's going to make this thing equal to 0 is x could be 0. Right, now that's coming from here. And then it could be 1 over 4. Right, that's coming from here. Change the sign of the constant divided by the coefficient. Or we could get negative 7, and that's coming from here. Right, so there's our solutions to this problem. What's going to make this expression undefined? These three numbers right here. So in 4, we've got this rational expression being multiplied by this rational expression. And to multiply, what we're going to do is we're going to factor everything in sight and then cancel any common factors. So let's start factoring now. We will get, let's get it to right here. In that top left, we're going to get x and x. And for the 10, I'm thinking a 5 and a 2. I can get a 7 out of that. Plus 5 plus 2 over, what are we going to get in this one here? Well, I'm thinking, well, x and x for sure. And then 40, I'm saying 8 and 5. 8 and 5, I can get a 3 out of that. So let's go with the 8 and the 5. And now the 40 is negative. So what sign do I use? Look at this product here, 8x, and this outer product is 5x. This one's bigger. So I'm going to use this sign with that product. So I'm going to associate the negative sign with the bigger product. I'm going to put a negative here and a positive here, times. Now, in this right top, this is the difference of two squares. So we're going to have conjugates. We'll get x plus 8, x minus 8. And in the denominator, let's see where we are here. How about x and x? And you know, for this 24, I'm thinking 8 and 3 because I can get an 11 out of that. So let's go with 8 and 3. The 24 is positive, so they're going to have the same sign, which is that middle plus sign, plus and plus. Now let's look for any common factors, and if we find them, we're going to cancel them. So how about over here, this x plus 5, we'll go with that x plus 5. This x minus 8, we'll go with that x minus 8 up there. These two x plus 8s will go, and it looks like what we're left with then is this x plus 2 and that x plus 3, but it's really this. It's 1 times x plus 2 times 1, which is just x plus 2, over 1 times 1 times 1 times 1 times x plus 3, which is just x plus 3. So there we go, and I'm going to go a step further. I'm going to say this is going to be true as long as x is not equal to, now take it back one step here. What can x not be? Look at these denominators. What's going to give us 0? Positive 8, negative 5, negative 8, negative 3. All right, so we have to exclude 8, negative 5, negative 8, and negative 3. Now in textbooks, they will probably just leave it like this. So even on exams, this is probably good enough, but I'm just going to carry it further to make the thing complete. Here in problem 5, we have a division, rational expression divided by a rational expression. We know what to do here. We're going to change the division to multiplication of the reciprocal. In other words, we're going to invert the divisor and multiply. So I'm going to rewrite this with this fraction here just flipped over. And there it is, like magic it appears. So what I did is I just flipped this one over. You can see this top is now the bottom. This bottom is now the top. But I changed the division to a multiplication. Now we're multiplying two rational expressions, so we know what to do. We're going to factor every one of these trinomials. So let's get to it here. We are going to have here, how about x and x? And the 16, you know, if we went 8 and 2, we could get a 10. I'm going to go with an 8 and a 2. They're both going to be positives, pluses. And in this bottom left, x and x. Now, 4 and 2 is not going to work with that 8, but an 8 and a 1 I can get a 7 out of. How about if we use a positive 8 and a minus 1? You know, the 8's negative, so these two numbers are going to have opposite signs. I'll use a positive 8 minus 1. That'll give me a positive 7. Times see what we get here. All right, how about x and x? You know I'm going to use a 6 and a 1. A 3 and a 2 is not going to give us a 7. But if I use, say, a -6 and a -1, I can get that -7 out of there. And then down here, how about x and x? And now I've got an 18. I'm thinking, 9 and 2 is not going to work. I can't get a 3, but a 6 and a 3? 6 and a 3 I can get a 3 out of. So let's go with a 6 and a 3. And now the 18 is negative. That's negative. So I'm going to use that sign here with the bigger product. So 6x bigger than 3x. I'll put that sign right here. So I'm going to get a -6 plus 3. And sure enough, -6 plus 3 will give me the -3. And now let's look to see if anything cancels. The x plus 8's cancel. What else here? X minus 6 and x minus 6. This x minus 1 with that x minus 1. So we got a lot of cancellation the way this was written. So we're going to be left with x plus 2 over x plus 3. And that's probably good enough, but I'm going to take it one step further. I'm going to say what x cannot equal, and we know we can get that if we just look back a step. So look at these denominators. What's going to make these things 0? -8, 1, 6, and -3. So I'm going to write those. So let's get that. We'll get -8, 1, 6, -3. And they're coming from here, right? -8, 1, 6, -3. But this one, we have to worry about this numerator. Typically, we don't worry about numerators because numerators can be 0. But you see, at one point, this one here was the denominator, right? It started here, we flipped it over. So this one here, that denominator became a numerator. So because it was a denominator, we have to worry about it. So what's going to make this one 0? We have a 6, but we already have the 6, and a 1. Well, we already have the 1. So it turns out this one did not add anything new.